Hey guys, today's topic is going to be on something called the surface area of nets. I'm going to try to get through this whole video during my planning period right now without daycare calling me to say that Harrison is sick and needs to come home, without my husband calling me to say that DirecTV is on their way, or without the DirecTV guy showing up at my door to come replace my boxes, or without the dogs fighting and barking in the background. We'll see if I'm successful. I'm a little doubtful, but we'll see. All right, here we go. Yesterday we talked about nets. A net is a two-dimensional representation that can be folded to create a 3D figure, three-dimensional figure. So when we talk about surface area of 3D shapes, we're literally talking about the areas of all the faces, which are the outer surfaces of a 3D shape added together. So those big prism shapes that we were holding up the other day, Mr. Ware was holding them up for you. Essentially, if I wanted you to find the surface area, I'd want you to find the areas of all of the faces of those prisms or pyramids, whatever it was, and then you just add them together. Now, this can also be done if we find the areas of all the shapes while they are in net form. So if you have net form, it actually makes it a little bit easier because then you just need to find the areas of all the 2D shapes and then add them together. So here's what that looks like. We're just going to do a few examples. And the first thing that I want you to do is name the 3D shape pictured below, and then label the net with the correct dimensions, and then use them to find the total surface area. So I give you a picture of the 3D shape. First, you're going to decide, is that a polyhedra, or does this have circles? Remember, that tells us which side of the flow chart are we looking at. Well, this is a polyhedra because it has all straight sides. And then once you figure out, okay, it's a polyhedra because there's no curves, it's either got to be a prism or a pyramid. And in this case, it is a prism because we don't have any triangles. A pyramid has to have triangles. And we have two congruent bases, right? If we count the top, that'd be 1, 2, 3, 4, 5. That's a pentagon. So we say that this is a pentagonal prism. That word's kind of interesting. I know many people say pentagonal just because it's a pentagon and then you tag on the AL, but if you talk in, I guess specifically, if you look like in a math textbook, it would tell you to pronounce it pentagonal. So what we want to do is we want to take the dimensions that are labeled on the 3D shape and label the net accordingly. So the first thing I notice is I'm going to trace out the pentagon that's on the bottom here. And notice that one of the sides of the pentagon is 13. So that's how I know that I'm going to label a side of the pentagon 13. Now, it is technically, we can assume that it is a regular pentagon. I'm going to allow you to assume that, which means all sides of the pentagon are 13, including like this one right here. And that's important for the rectangle as well. So all the sides of the pentagon are the same. The other part of the pentagon is this 8.9. That's pointing to a segment that starts at the center of the pentagon and then drops down to a 90-degree angle. You may remember this is called, so that's 8.9. This is called the apothem of a regular shape. So this is back to last chapter. Using our area formulas, we're going to end up using the apothem of that pentagon. The only thing we have left is this 8. So if you look at the small rectangles on your prism, that 8 represents the shorter side, which would be like this part of the rectangle and this part of the rectangle. So our goal is to just find the areas of all of these shapes. So let's take care of the pentagon first. And I recommend you labeling your work like I'm going to label it here too. Okay, for the pentagon, the formula, if you're looking on your formula chart, the area of a pentagon is 1/2 AP. So we know that A stands for the apothem, which we already have. So that'll be 1/2 times. We know the apothem is 8.9. P stands for the perimeter. And the perimeter stands for just all of the edges of that shape added together. So we know that one side is 13 units long. It's a pentagon, so it has 5 of those sides. So then when we calculate 13 times 5, we get 65. So the perimeter of this pentagon, P, will be 65. So then we're going to multiply this all together. 1/2, which you could put 0.5 if you want your calculator, times 8.9 times 65. And you should get 289.25. That is the area of one pentagon. I stress the word one because the net, or the 3D shape, has 2 pentagons. So when we find the area of 2 pentagons, we're going to multiply 289.25 times 2, and we'll get 578.5 units squared. That's the area of 2 pentagons. Now, that's not our final answer. That's the area of the pentagons. The next thing we have to find is the area of a rectangle. So the formula for the area of a rectangle is you can do base times height, or you could do length times width, which is, we know one side of the rectangle is 8. We know the other side is 13 because they're all going to be the same. So then when we multiply 8 times 13, we get 104 units squared. Now, that's one rectangle. So you can't forget that you have multiple of each shape. So then we need the area of how many rectangles are there? We need the area of 5 rectangles, which means we're going to take 104, multiply it times 5, and you should get 520 units squared. So you found the area of the 2 pentagons, the area of the 5 rectangles. So to get the total area, we're going to add those two together. 578.5 plus 520, and we'll get a total area of 1,098.5 units squared. So that is the area of that the surface area of that pentagonal prism using what we know about folding it down to make the net. Okay, example 2, our next shape. I want you to label this. So it says, I think y'all's may say example 1, by the way. I forgot to correct it on the copies that y'all have. Oh, no, y'all are going to say example 2 because it's the same as mine. Okay, sorry, side note. Anyway, name this shape. Hopefully, you're pretty great at these parts now. This is just a cylinder. That one's very common. So I'm going to take those 2 dimensions that are on the cylinder, that 4 and that 7, and label those on the net somehow. So I think 4 is the easier number. It's pretty clear to see that 4 goes from the center of the triangle to one of the sides, which stands for the radius of that circle. And then 7 stands for the height of the cylinder. But if you got to think about it, if you unfolded that cylinder, like almost like taking the label of a can of soup off, that stands for this height of that rectangle. And they're the same on both sides, so that's 7. Okay, so what we need to do is find the area of the circles and find the area of the rectangle and add them together, and then we have the surface area of a cylinder. So let's do that. Let's first find the area of a circle. Well, using our formula charts, area of a circle is pi r squared. So for us, that'll be pi times the radius of the circle is 4, which 4 squared is 16. And then it doesn't tell us to keep our answers in terms of pi. So we're actually going to plug 16 in our calculator and we'll get an approximation. We'll go ahead and round to the nearest hundredth anytime we have to round. So 16 pi to the nearest hundredth is 50.27. Now that's the area of one circle, but we have 2 circles. So the area of 2 circles will be 50.27 times 2, which will get 100.54 units squared. So that's one part. That was the easy part. Area of the 2 circles, done. Okay, the next thing we have to find, so that takes care of the circles. Then we just have to find the area of this rectangle and then add it there. So earlier we said the area of a rectangle is equal to length times width, or base times height, however you want to think about it. So I need you to think about this. We know that the width is 7. So I need you to think about what is the length of the rectangle. So we know this part is 7. The problem is we don't know this highlighted green length, right? Now you could maybe use the 4 for the circle somehow and figure out how many times that 4 would lie on this. But what I want you to try to think about is, how did we get that rectangle in the first place? When we took the cylinder and we unfolded it, what part, or think about folding this back again. If I were to fold up this net and make my 3D cylinder again, where would this green length match up to? What part of the cylinder does that match up to? Well, if you think about folding this, that green length would end up tracing around the circle. So what that means is, we know the width of the rectangle is 7, but that means that the length, or whichever one you want to call length and width, it really doesn't matter, but this is important. The length of the rectangle is, what do we call the distance all the way around the circle? It's going to be the circumference of the circle. The length of the rectangle is actually the circumference of the circle. So let's find what that is. The circumference of a circle is given by the formula 2 pi r. So that's going to be 2 times pi times the radius is 4. 2 times 4 is 8. And then again, we're going to be rounding. We're not going to leave answers in terms of pi. So then 8 pi to the nearest hundredth is going to be approximately 25.13. 25.13. So again, I want to reiterate, this is the circumference of the circle, but this is also the length of the rectangle. So then when we go back to our rectangle area formula, which is length times width, we already know that the width is 7. So for L, I'm going to plug in what we just found for the circumference, which will be 25.13, times, we said the width was 7. And then we're going to get that that's approximately 175.91. That's the area of the rectangle. Now, we've had to multiply lots of our other areas after we find them because there are multiple of that shape, right? Here, we found the area of one circle, but we multiplied it times 2 because there were 2 circles in the net. Up here, we found the pentagon, but multiplied it times 2 because there were 2 pentagons. And then we multiplied the rectangle because there were 5 rectangles. But here, there's only one giant rectangle. So once you find the area of the rectangle, you don't have to multiply it by anything else. So then we just take these total areas, the areas of the 2 circles, plus the area of that rectangle. And then we will get our total area, which will be 100.54 plus 175.91, which should be about 276.45. We're still in area, so we've got to get back to that habit from last chapter, where our answers are going to be written in units squared. Units squared. Okay? So your job now is to take these examples, and I want you to do exactly what we did. I want you to take the 3D shape, take those dimensions. Notice for number 1, I've actually already labeled them for you. So your job is just to take the net, find all of its dimensions, and add those up, or do what you need to do to multiply them to find the areas of all the rectangles. Number 2 is very similar to one of the examples we did, except instead of a pentagonal prism, this one has 1, 2, 3, 4, 5, 6 sides. So that one's going to be hexagonal. And then number 3 is a pyramid. Okay, so you've got some triangles here, so you'll be using the area formula for a triangle. and then number 6 is another type of, or sorry, number 4 is another type of pyramid. Okay, so your first job is to name the 3D shape, and then if it's not already labeled, you want to label your net with all of these values, and then use those to find the areas of the 2D shapes, and then add them all up to get your total area.